Hello everyone. We're going to continue along with Chapter 2 material today. This one's going to be section 2.1, and what we're going to do is go over basic quadratic functions. So we're going to do a little bit of review. A lot of this material we have learned before. We're just going to put them into context, bring it all together, and use it to help us graph some quadratics. Okay, so I'm going to get started. So a quadratic function, we're going to learn how to write it in vertex form, and basically we're going to learn how to start out in the standard form and then put it into vertex form. We have to learn what that is as we go forward. And then there's also a different way, the usual way that we can do it, and one that we've done before is completing the square. I'll kind of review that, and then we use that completing the square to put it in vertex, and then a formula that we'll be able to just go directly into that. So here is the graph, just basic graphing functions. We know this, that here is a basic ax squared plus bx plus c, that it opens down if a is less than 0 and opens up if our a is greater than 0. Okay, and here's the vertex form. And that vertex form should look familiar to you, is that in that it's also known as the transformation form. And I'll kind of go with that as a review. So transformation form, okay, slash vertex. Okay, so from what we've learned before from our study of functions, we have some basic graph here, and this was our basic function, our base function. Y is equal to x squared, so f of x is equal to x squared. And then we learned that we could do things like do a transformation, move all of this graph over to the right, move it up and down, and we learned from our transformations that we could form another function. And this, I want to make this a little more generic by saying here is ax squared. So this is the a, where if it's negative, we flip it a positive here, and that we can do some scaling. Okay, stretching, if you will. So we can do, if we started with this, we can move it over. So if we did the transformations by moving this over c units to the right, and then if we take this and then move it up, this vertex is now at ch. Okay, and that's the vertex form or the transformation form. We just did what we know from last chapter, that we could do this transformation. So this point at 0, 0, depending on the transformation that we wanted to do, would end up at like ch for that form. Okay, so one more piece of information. So I'm going to go down and I'm just going to do just the graph. So here's the kind of the generic graph. Now we're at, here's our vertex, and that vertex is ch. C units to the right and h. That's our vertex. And this line that goes right through the vertex, x equal to c, we call that, let me open this up a little bit, we call this the line of symmetry. Okay, so if we know something on one side, so if we knew the y value for this point and we knew what that distance was, all we have to do is just add it, and that's going to be the same height right around here. The same distance from that line of symmetry on both sides. And we'll see this later on when we find the y-intercept, and I'll use this to kind of say, well, here's another point that we could use from there. Okay, so that's the line of symmetry, or the axis of symmetry. Okay. So we're going to use that to graph this, and we're going to add some information. We'll pick it up from here's the basic and then go from there. So I'm going to try to do this kind of in the middle of my board here. Okay. So I want to graph, put this up, bring it down just a little bit. So I want to graph f of x is equal to x minus 3 squared minus 9. Okay. So I note here's A is equal to +1 in this case. That's understood, +1 right there. The vertex I just read off. It's in that form x minus, so that vertex is 3 and -9. So I would go over here and I would count off 1, 2, 3 on my grid. Hopefully I would have a better grid. And then down 1, 2, 3, 4, 5, 6, 7, 8, 9. So here would be 3, -9. Okay, this would be my -9, and here would be my 3. Okay. So now, A is equal to 1. That's from my other piece of information. So +1, it opens up. Okay, so I know it's going to go up. And I kind of set this up to start with, in that I'm looking to see if I'm going to have any x-intercepts. Okay, so I'm below the x-axis. If I plot this point, I'm below the x-axis. I'm opened up, so eventually I'm going to have an x and a y-intercept. Okay, it's eventually going to continue up. Okay, I'm always going to have a y-intercept. Okay, I'm always going to cross over here with one of these little arms, but I'm not necessarily going to always have x-intercepts. If this was a -1, it would be open down, and there's no way if I'm below the x-axis and it's open down that I would ever have x-intercepts. Okay. So let's start out. Let's kind of let's do the x-intercepts first. Okay. So the x-intercept, I want to set my y equal to 0 and solve from this vertex form. So I want to go here. I'll be careful not to erase my writings here. X minus 3 squared minus 9. And then I solve. And this steps, I'm always going to do this the very same way. I want to start in that transformation form, the vertex form, set my y. This is the y value, right? This thing in here, that f of x, that's the y value. So I want to solve, and I want to take this over here, do the outside first, and then take the square root. So +9 gives me 9 is equal to x minus 3 squared. I'm going to take the square root of both sides, and I've got to do plus and minus here. So the square root of 9 is 3, so plus or minus 3 is equal to x minus 3. I take the square root of both sides. And now I'm solving for x. I'm going to move this over here, so I'm going to add +3 to both sides. And I get my x, I'm going to write it this way, 3 plus 3 plus or minus 3. So I'll have two values, 3 plus 3, so I'm going to write it down here. 3 plus 3, my first one is 6. And then my second one is 3 minus 3 is 0. Okay. So that's all along the x-axis, x equal to 0. So right there is a 0, 0. And then 3, 4, 5, 6. 6, 0 is a second one. Okay. Now I'm going to go ahead and do this. The next step I normally do is the y-intercept, but watch what's going to happen here. That just happens to be the x-intercept and y-intercept. Okay. So for my y-intercept, I set my x equal to 0 and then solve. So here's my 0 here. So my f of 0 is just going to be 0 minus 3 squared minus 9. My minus 3 squared is 9, 9 minus 5, so that is 0. And again, that's the y-intercept. It just happens to double up as the y and the x-intercept. So if this is right in the middle, and if I draw down here, let's go ahead and set up our axis of symmetry. It needs to be a little straighter. So our axis of symmetry is x equal to 3. It's going to come up here and go through. So I'm going to bring this down like this, hook that in, and then it's going to come back up like that. And I want to make a note now, this we've already got the x-intercepts, but if we'd had a y-intercept, I'd say how far am I from the x-axis, and that y value is going to be the very same thing. So here, 3 minus my 0, so this distance to there is 3. And if I start at 3 and add the very same thing, so I'm doing 3 minus 0, that's 3. Take this and add it to 3, 4, 5, 6. That gives me the same 0 value. It's symmetric all across here. And we'll see that again as we go forward. Okay, so in general, we want these points. I want the vertex graphed, the x-intercept, and the y-intercept. And if we've got a y-intercept that's a little bit different, go ahead and put that extra value across. Okay, so here's another one. So graph f of x is equal to minus x minus 2 squared minus 1. So again, I'm going to start out. Here is my axis for graphing. And I'm going to do the vertex. The vertex I read off here is the x minus. That's what I'm looking for. So 2, negative 1. I've moved the graph to the right 2 from 0. That's plus 2, and then down 1. So here's 1, 2, there. Here is 2, negative 1. And now I note A is negative 1. There's my A. Okay. So this says it opens down. Okay. So here, I go ahead and set this up just like this. And that tells me that I'm below the x-axis, x and my y, opens down, so it's not going to cross that x-axis. Okay, so just from noting these couple of things, we already know there's going to be no x-intercepts. Okay. So let's go ahead and add in our axis of symmetry. So here is right through that vertex up. This is the line x is equal to 2 from that vertex. Okay, and so this is symmetric. All these pieces are symmetric. So if I know one on one side, the very same thing. So the piece that's always going to be there is some y-intercept. So we're going to find the y-intercept. And we do that by setting x equal to 0. So f of 0 is just negative 0 minus 2 squared minus 1. The negative 2 squared is plus 4. And here's the negative on the outside. So minus 4 minus 1 is minus 5. So down here, 1, 2, 3, 4, 5. Right there is going to be my y-intercept. So this is 0, negative 5. And I note, so here, I am 2 units from this y-axis. And I know what this value is. This is the negative 5. So if I go 2 more, 2 plus 2, so I'm at 2, and I add that 2 over this side, I'm at 4, negative 5. So this distance is 2. From 2, this distance is 2. So that gives us a 4, negative 5. And I'll kind of redo this for you. That point is 4, negative 5. Okay. And that's the way it looks. 2 over this side, 2 over that side. I want to have the same negative 5. Okay. So one more. What we're going to do as we go forward is start looking at that general form the y, or f of x, ax squared plus bx plus c. We're going to go down and get that into the form that looks like the vertex or transformation form. We're going to be able to move this to here, and then we're going to do the graphing the same way. So this is the piece that we're always going to do. I read off, once I get it here, the vertex. This is a plus, so this has got to be at -2. I've taken that basic graph and moved it to the left 2. And then there's my -1. Okay. So -2, -1, and now my a is equal to +1 opens up. So if I open up, I'm going to eventually cross that x-axis, and where it crosses, those are the x-intercepts. Okay, so let's find those, and we find this by setting y is equal to 0 for our x-intercepts. So 0 is x plus 2 squared minus 1, and then we're going to do the very same thing. This over here, add +1 to both sides. That gives us there. And then I take the square root of both sides, and this needs to be plus or minus. So the square root of 1 is just 1, so this is plus or minus 1 is equal to x plus 2, and then I'm interested in x, so -2 minus 2, and that gives me -2 plus or minus 1 are my x-intercepts. And this is -2 plus 1, so x is equal to -1 minus 2 plus 1, and then -2 minus 1 gives us our -3. So here's our -1, and then 1, 2, 3. This is our -3. And notice that our line of symmetry is that x is equal to that line, x is equal to -2, and this is 1 over 1 over till I get to my x-intercept. So it's right in the center there. Okay, so from here, this is going to go up, symmetric around there, even though it doesn't look. My graphing isn't great. But here, now we need to do the y-intercept. It's always going to cross the y-axis. And what do we know about that? That's where x is equal to 0 all along here. So I'm just going to set my x equal to 0. And I'm going to set this over here, g of 0. This is just going to be 0 plus 2 squared. 2 squared is 4 minus 1. So that is 3. So if I keep the same scale, 1, 2, 3, 0, 3. I'm going to go through there. And now this is 2 units from -2 to 0. That's 2 units. So I'm going to add or subtract 2 from here. So this would be my -4. 2 units. And from, so from -2 minus 2, that would be like right here. And then that would be -4 with the same value as my y. And then it would just go straight through there. Okay. So let's look at Desmos. Does a much better job. And again, I just do these sketches, or we do these just to do as something quick to get an idea of where the things are, how everything is set up. And if we needed a detailed, we would go to Desmos, and I'll go to www.desmos.com. My graphing, and then let's just put this under here as y is equal to x plus 2 squared minus 1 and that's what we look like. So here's our piece. We said we should have labeled this. This was our -2, -1. We had it down, we just didn't add the label here. So if I go over here, there's the, let me get it in here, -2, -1. So that's the vertex up here. That's my 0, 3. And if I go across here, so this from here to here is 2 units. And then I work backwards to -3, -4 right there. If I can get that right on there, I've got the -2. There's the -4, 3. Okay. So what if we're not given this? We're giving it into another form. And this is the more common form of a polynomial. So quadratic is a form of polynomial. We'll talk more about that next time. But I would like to go, this is very hard to graph as the way it stands. Okay, I'd have to start picking some x's and then just graphing out this thing and hope that I would get a good picture, not just a piece of it. Okay, depending on how far I went over, and if I stuck around here, I may not even get the vertex in. Okay, and then if I did, my values may be further across there and I wouldn't get all of that information. Okay, but I would like to convert this into that form, and that's what we're going to do here. Okay, so we've done this when we were looked at just a general view of completing the square, and that's what we want to do. We want to complete the square. Okay, and before I get started on completing the square, let's kind of review what we're trying to do here. And I'm going to do a couple of different versions. So if I squared this, I want to note the form, and then I'm going to kind of work backwards when doing this thing. So if I'm going to square this out, I'm going to square the first one, multiply the two together, 1x, and then times 2, so that's doubled, or 2x. Same sign, and then I square the last. 1 squared is 1. Okay, so that's what that looks like. X plus 2 squared, square the first, 2x doubled is 4x, and then square the last one. X plus 3 squared, square the first, 3x doubled is 6x, and then I square the last. 2 more, and I'm going to stop. X squared, 4x doubled is 8x, and then square the last, and then 1 more. Five x times 2 is 10x, and then I square the 5, and that gives me 25. Okay, so I do this to kind of make this general note of what we're doing. If I take this, and if I divide this by 2, 2 divided by 2, and then square it. 2 divided by 2 is 1, 1 squared is 1. Okay, notice that. If I do this, 4 divided by 2 squared, 4 divided by 2 is 2, 2 squared is 4, that's exactly what I get. 6 divided by 2 squared is 3. 3 squared is 9. That's exactly that. 8 divided by 2 is 4. 4 squared is 16. Half the 10 is 5. Square it, that gives us 25. Okay, so what that's going to give us is a method to generate this last number. If this was a perfect square, and we wanted to generate this piece of it, we're going to take half that middle term and then square it and then go from there. Okay, so we need to balance. If I'm adding things in, I'm going to subtract them back out to keep my balance for my equation. So notice that I could add 0 into any one of these, right? Okay, so that's what I'm going to do. So f of x is equal to 2x squared plus 20x plus 42, okay? Factor out the leading term. When I was looking at these, they were all the coefficient is 1. So I want to, first of all, I want to factor these out. These are the only ones I want to work with. I want to move that over to the left or to the right. We'll deal with that later. So x squared plus 10x, there's my 42 that I'll work with later. Here I want to take this, complete the square. I want to make this a perfect square and then compress it. So here I had 10. So again, I want to take divided by 2 and then square it. So this is 5 squared. If this was a perfect square, I would have a 25 right there. Okay, and then I can rewrite this by x plus 5 squared. Square the first, multiply the 2 together and double, and then square the last. Okay, but now I just can't arbitrarily stick in numbers where I need them. Okay, bad. So what I got to do is sit back for a second and say, now for in this case, since this is not 1, I'm actually here, if I distribute 2x squared, 20x, I really added in a 50, 2 times 25. So what I want to do is subtract or do the opposite of what I did. If this was -2, this would be -50. I would want to add the 50. Okay. So this is the form that I want it. And then I just take care of this. I group those together. 2x plus 5 squared minus 8. And now this is the vertex / transformation form. Okay, the vertex, I'm moving this over to the left, so I've got a 2x squared that I'm starting with, moving it over to the left, 5, and then down 8. So -5, -8 is where that vertex is now. Okay, and then we can pick up everything else. Okay, so I'm going to go over here. Give me a quick set of something to graph with. -5 over -1, 2, 3, 4, 5. Down 8, -1, 2, 3, 4, 5, 6, 7, 8. So right there is my vertex at -5, -8. My A is equal to 2, so that means I'm up. Positive number, A greater than 0. So it looks like I'm going to have some x-intercepts, and I'll always have a y-intercept. Okay. So I want to find my x-intercepts. I set my y equal to 0, and that's my f of x. Okay, so 0 to x plus 5 squared minus 8, plus 8 to get that over there. Divide by 2. And now this is the 4. Square root of both sides. I want to get rid of that, the square, so I take the square root, and then this has to be plus or minus. So plus or minus 2 is equal to x plus 5, and then I want to subtract off my minus 5, or minus 5 both sides. And then I just write down my x-intercepts. -5 plus 2, -3. -5 minus 2, my -7. So -3, right down here, is my axis of symmetry, x equal to -5. I'm 5 away, sorry. There is, sorry, -3, -1, -2. There is my first x-intercept at the -3, 2 away from here, 5 minus 3, the 2. So if I go 2 more this way, -6, -7, and that's where I would go here. I'm running out of board, so I'm going to continue this like this. Okay. So now what other pieces that I can do, I'm going to add, there's my axis of symmetry, the x is equal to -5. So I'm going to add this enough up and see the y-intercept. Well, for the y-intercept, I'm just going to do f of 0. Now, in this case, if I have taken the standard form and got it down to here, I want to do this back at the y-intercept. The reason I do this is because now this evaluated at 0 is 2 times 0 squared, 0 squared 0, 2 times 0. This goes out, 20 times 0 goes out. I'm only left with this term, and this is the y-intercept. For a polynomial, no matter how big, all these got x terms, the last is when all this is 0, this is the y-intercept. So up here, and I'm going to put a little break in here and go all the way up. This is 0, 42. Okay. And here now I am 5 units from this value. So now over here, so from the axis of symmetry, x equal to -5, this is 5 units. So -5, -5, this gets you out here at -10, -10, 42 is that one. So that gives you a freebie of a second point to do this. Okay. So let me bring up Desmos again real quick, and I want to go over each one of these and kind of show you, let me kind of bring this out to just that piece. Open this, kill this. So here was the original. Two x squared plus 20x plus 42. That's the original. Plus 42, hold on. There's our -5, -8, okay? And then we graphed out to the -3, 0, the -7, 0, and then all the way over here where it crosses, that's our 0, 42, that's our y-intercept. And now if I go over here to -10, that's going to be our -10, 42, if we can get it right there at it. The -10, 42. So if I just happen to, if I graph that alternate form, so here's our vertex forms 2, x plus 5 squared plus 42, sorry, that was now -8. I only see one graph, and if I turn that one off, that's that version. There's that, there's the green, there's the blue. These two are the same equation, it's just a different form. This is a much more desirable form in that I can read off the vertex -5, -8. So that is going through and doing a complete the square, and we've worked several through completing the square, and we'll do some more in our lab. But I want to go here. This information that we've done before, we can look at this and say, okay, we've got 1x intercept, 2x intercepts, b squared minus 4ac. This is the discriminant that we've looked at in the past. And here we have no x intercepts. This is just completely complex. And this is kind of summarized by, if we looked over here, the vertex, we identify the vertex opened up. And if we're down below the x-axis opened up, we're going to have two x-intercepts. If we just touch it, we'll just have one. And then either above or below and open down, we have no x-intercepts, and those are complex roots. Okay. So that was completing the square to get the information that we needed. Okay, to get it into that vertex form, we completed the square. So that's one method. There's also a formula that we can use. And it turns out that if we're given, here's the general form of a quadratic, the x-coordinate is just that vertex is given by x is equal to negative b over 2a. Okay, almost looks like the quadratic formula with only one root. And that's basically moving it over to give us that axis of symmetry. Okay, so this is a formula. All we have to do is evaluate negative b over 2a to find the x-coordinate of the vertex. And to get the y value, all we do is take this value, stick it back in, and evaluate the function. So the vertex is basically given by negative b over 2a and f at negative b over 2a. Okay, so let's give this a try. Okay, so if I do f of x is equal to negative 3x squared plus 48x minus 165, okay, I don't want to complete the square, I have to factor these things out, do a lot of the stuff, but at this point, I'm just going to use that formula. This is negative b over 2a, okay, 2 times a. Here's my a, that's my negative 3, my b is equal to plus 48. Okay, so the vertex, the axis of symmetry, this is also the axis of symmetry, is just equal to negative b, negative 48, divided by 2 times the a, and that's the negative 3. So negative 48 divided by negative 6, and this will give you plus 8. Okay, so my vertex x value is at 8, and I don't know the y value, but if I know the 8, the y value is just connected by the function. So f at 8 is minus 3, 8 squared plus 48 times 8 minus 165. So I just evaluate that. And if I do this real quick on my calculator, and I get this to be 27. Okay, so what do I do with this information? So that goes right in there. That finishes up. Here's my vertex, and then I've got everything. What I want to do is write the function in vertex form. Okay, so here's how I want to do that. So I don't need this yet. I'm going to say f of x is equal. It's got to be in this a. This is the very same a. Just like if I factored it out to complete the square, that goes out front, and now I know everything else. X plus 8, so this is at minus 8. X minus 8, that's where my vertex is. Moved it to the right 8, and then plus 27. Okay, and then we can continue the vertex. We've got it. We can do the y-intercept, set x equal to 0. I would do it here to get the negative 165, set y is equal to 0, and solve. This needs to be a square to get the x-intercepts. Okay, so if I go again back to Desmos, cancel this out, and see if this gives us that equivalent graph between these two. Are they equivalent functions? So I have y is equal to negative 3x squared plus 48x minus 165. So we get it here, open down because that's negative 3, the negative. And then our new y is equal to negative 3x minus 8 squared plus 27. So if I slide this over, that gives us everything right there. 5, 0, negative 11, 0. Turn that off, I get this one. And that's the way these things are. Okay, the very same function with the same graph. Okay, so we'll work some more of these while we're in class. That should get you started understanding what we're doing. We're trying to take a general quadratic, the standard quadratic form looks like this, and then getting it down to a transformation form or a vertex form that we can read the vertex 827. If I click up here, there's my 827, that's the vertex. So we're using that knowledge of transformations to get us to something that we can understand, okay? If I do a transformation on a base function, what does it look like? So this is, if I go here, my y is equal to negative 3x squared. This is the same thing. So this is the same shape as here. Everything's going to be the same except this point is now moved over and then up. Over 8, up 27. Okay, so this now looks like this minus 8 plus 27. And that gets us there. Okay, so I started this at 0, 0, move that to the right, my 8 units. Now this is the 8 units, x minus 8, and now I'm just going to move it up to my 27. So let's just write this as 27 to get it all the way up. Okay. So I hope that helped. We're going to be practicing this more during lab time. So I will see you then. Have a good day.